Okay, so we're going to start talking about graphs now. So when you're doing a graph, let's just talk about, okay, with graphs, we always have two variables involved. So we just did an example, the cost and the t-shirts, okay? So this is always called an x-axis, and this is called a y-axis. Okay, coming from a middle school, is this basic enough? Like, have you done that stuff? Okay. Okay, this one is called the independent variable, and this one is called the dependent. We talked about those words yesterday. What does depend mean?
It means it depends on the independent to do the thing.
It depends on that. Okay. So this one depends on what's going on to that. Okay, so I'm going to ask you a question about the last example. Does the amount of t-shirts depend on my cost, or does my cost depend on the shirts that I buy?
Sure.
The cost depends on how many shirts I'm buying. So which one would you put on the bottom? Shirts. And the cost depends on the shirts. Okay, so that's something to know. Okay, independent, dependent, this one relies on that. So you can think about real life. Yeah, a cost of something depends on how many I'm buying. Okay, then did you ever notice that what was happening as I bought more and more shirts?
The price got higher.
The cost went up, up, up. Okay? That kind of idea. Okay, so that's just the basics of just any kind of graph. Okay, so we have a word here. It's called interpolate. It means to analyze the data within the given parameters. Is this not a spot? Page? Anybody help him out? Oh, because we did a separate notes booklet, right? Sorry, sometimes my units I do separate.
I think instead of separate, I think it should be over.
Okay, so here I go. Let's read problem 1. A weather balloon records air temperatures and altitudes. Here's their relationship, altitude and temperature. Do you understand what altitude is, just that word?
Yes.
How high you are, right? Okay, so obviously when you're in an airplane, you're at a high altitude.
Check your altimeter. Is it broken?
Okay, okay, I'm going to ask you this question. Which makes more sense? This has to be a life thought. So just general life. Does your altitude depend on the temperature outside, or does the temperature depend on the altitude you're at? Okay, so temperature depends on the altitude. Did they do it right? Oh man, this is funny. This is supposed to be like this bad spacing. Did you guys see that? Is yours like that too, or mine? Another one? Oh, 11.4. There. That's just gonna bother me because of my brain. It's spacing. Okay. So altitude has to go up to 1800. So if you're gonna graph this, you have to think about, am I going to draw one tick, one tick, one tick, all the way to 1800? Is that practical? No. So they picked 200, 400, 600, okay? So they picked a scale. So when you're graphing stuff, you're going to have to pick a scale. What do you see that they did as an increment? Every 200. Okay, and then the temperature this is pretty small numbers, so you could have done ones on that. That's fine. But they picked what as a scale? They picked 5. Okay, so here's what we're going to do. At an altitude of 600, okay, so I found the altitude of 600, okay, I'm going to be using a ruler here. Okay, so what I want you to do is from 600, you're going to have to go straight up from 600.
7.5 maybe.
So I hit my line right there.
8.
And then I'm gonna now try to match the height it's at. And 7.5 is a great answer. It's an approximate, so a little bit of wiggle room. 7.5 is great. 8 is a great answer. Okay, but how many of you forgot to do this on your test? I'm going to deduct this person. Okay, next. Now I want to approximate the temperature or the altitude when the temperature. So where am I looking for a temperature? I'm looking on this side. So negative. Would you agree with me that this is the height I have to be at? Does that make sense? Negative 7.5. Okay, so what am I going to do? I'm going to now draw a cross till I hit, and I hit, and then once I hit, now I'm going to go straight up. Okay, so some of you were at 1600. Okay, so it's kind of like drawing a box to match up and down, straight across. Okay, so this one I went straight up, then across. Here I did across and then over. Yeah, I had a little bit over 1600. Some of you said exactly 1600. I feel like I'm over that, but.
I'm still using a marker, so.
Yes, my marker's thick.
50. I said 700. 50.
Okay. I don't know, any of those pretty good answers acceptable. It's an approximate. As long as you're understanding your process and you're close-ish. Okay, so on this graph we have landing on airplane altitude. Okay, so this question has time and altitude. So it looks like when I'm landing a plane, the altitude is depending on the time I'm at. Okay? Right? Does that make sense? The altitude depends on the time that's elapsed, right? So as the time goes on, the airplane is getting lower and lower and lower as the time is going. Okay. What is the plane's approximate altitude at 50 seconds? So I need you to go to 50 seconds And do you see that it's right between? Okay, so here's my 50-second mark. So I'm going to go straight up. I'm going to go straight up until I hit the graph. And then from that, I'm going to go over. And that's my answer.
10 kilometers.
10 kilometers above ground. At what time? What? What's that? What? Kilometers?
Yeah, I'm not sure that's quite accurate to the positioning of an actual plane during render.
At what time is the plane's altitude approximately 11 kilometers? So this time I'm going to do this. Here's 11 kilometers. So what am I going to do to start? This time I'm going to start across. Okay, so here I started up, then across. Okay, now I'm going to go across first. So go across at 11. And then straight down. I'm going to go with a 45. Okay, these are me just color coding my answers so that you can see. So I did the yellow work, and then this was the orange work. Okay, I like this. Does it make sense to connect the points with a line? So does it make sense in real life to continue not only just the points, but everything in between the points? Yes. Why? What does that mean?
Because then you can tell when everything is.
Because
Okay.
it makes it way easier to solve equations.
No. Just real life. Real life. Why? Okay.
What are you trying to...
So I'm going to give you the different example. Let's do the t-shirts and the cost. Okay? The t-shirts and the cost. Here I'm doing that. And I'm not going to put a line between these. And here I am going to put a connector line.
To show which way it's going.
No.
10 years.
No. Any other ideas?
It's consistent.
You got it. It's consistent. So close, I think. That one's the best so far. What's the difference between t-shirts and a plane moving?
It's moving.
So why can't I include the betweenies? Why can't I include between here?
Because shirts are at a total. What? Shirts
This can be divided into more than half or...
There we go. Shirts. Can I put something in the middle? Can I sell 2.5 shirts?
No.
No. So are t-shirts just on the dots?
T-shirts would be, but
Okay.
it depends on what you're doing now. Because a plane, if it's moving down, then it has like...
Okay, but does the plane jump from here to here? Or is it going to continue in the middle as well?
It depends on what it is.
Right. So in this situation, why did I draw a line?
Because the plane has to go down the whole...
The whole way. The plane So give a reason. The plane is continuous between the points. Does that make sense? My plane didn't move from this dot to this dot, like jumped. It didn't jump there, it continued. And you can track it anywhere in between, okay? So t-shirts, I can't have in-betweeny t-shirts, right? Does that make sense? Do you see them? Okay, let's move on to the next word called extrapolate. So, what did we do for interpolate? We analyze the data within the given. So what do we think about extrapolate? And we're going to analyze the data outside the given. So we're going to take the pattern and then we're going to predict where it's going or where it was before it started or whatever. Anna's kayaking up a coast, and then this arrow shows her course. Extrapolate the values of the coordinates where Anna will land. So do you guys understand what's going on?
She's kayaking.
So we have an arrow showing her. So here she started. Do you see that? She started here.
What? There's no line there. How'd she start there?
She got chopped off by a plane.
No way.
And then,
She's supposed to look different.
Is the dotted line where she hikes?
I guess,
Hiking on the water.
She kayak. Swam there first.
isn't it portaging? Isn't that the word for it?
But, yeah, okay. Okay.
Okay, so here's where I'm heading. I want to get to Graham Island. I'm trying to get towards this. Okay, so here's what I'm going to do. I'm going to take my pattern, okay, and I am going to extend it. So remember how I said the word extrapolate means go beyond. So this is within, so I have to go beyond. So I'm just going to make a big line. I can do anything on this line. You guys are probably smarter at geography than me because it's been a few years. Latitude is north-south, right?
Yeah.
And longitude. What is our border? What's our border? U.S. border. What parallel is the border to the North Dakota? 49th parallel.
How do you know that? Of course he knows.
Dolphin is on the 55th parallel.
When you guys are on number 1 highway, isn't there a sign past Winnipeg that says this is the dead center of Canada?
Oh yeah.
Oh, yeah.
What longitude is that then?
59 or something.
No.
I don't know. I don't pay attention.
Did you just make that up?
Yes.
Probably like
I mean, at the equator it's 0-0. Right in the middle of the gosh darn equator.
Yeah, but that's not somewhere in Central.
Okay, so can you use the line? Use the line. When do you hit this? What do you think about your numbers here? So what are you going to do? You're going to have to kind of take your line. Where does it intersect? Kind of go across and go up. So this is extrapolating. Okay, seeing which numbers correlate to each axis. Across and up and down. what is, okay, hold up. What's happening on this scale?
There's numbers.
What do you think?
No.
There, this to this is 1. So what's each little
0.1.
0.1? So if this is 54 and I'm actually maybe 2 above it. I don't know. Did anybody else
Where?
1 above it? 2 above it?
I got 3 above it.
Does the Grandma Island, are you trying to reach the words of the Grandma Island or where it starts?
I'm just went dead center in the middle because
Of what?
Graham Island. I kind of just went into the middle of it.
Of the words.
Underneath Graham, above Island.
Yeah, I don't know. I just took like right there.
But like the island starts like
Oh,
when she hits
I
the
see. Like here.
like
Is that what you mean?
Like where the thick line coming out of the island.
Yeah.
That's when she,
Like here.
yeah, when she hits the island,
Oh, I see.
not the words. What?
Words. Okay, time out. Henry says we should maybe reevaluate what we just did. Okay, so I went to the word, but Henry's saying, why don't we do this one? I don't want to go to the word, but this, do you see your drawing? This is the island where it starts. You know what I mean? Yes, that's a better idea. Let's do that. Okay, do you know what I mean? Like there's the island. So when did I hit the island? So if I hit right here,
53.7.
I'm going to go kind of across. And I'm going to go up.
And there's
Okay, so I'm going to revamp my answer a bit, hey? Okay. I drew so much on my map here that I might not be able to read it. What did you guys get going? What's that?
It's a little confusing after seeing multiple things happen.
Okay, so I'm going to just draw like...
It's not like this scale, I don't think is 0.1.
Is it not 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 11, 12, 13, 14. Not 10. Okay. Okay. So here is the deal. I gotta redraw my map because I've scribbled on it so much. So basically, this was the journey, and then we were extending it to figure out when we got to the edge of the island. Okay? So I'm sorry, the first time I did it, I was going to the word. Okay, so what did you guys kind of come up with an approximation? When you hit, does that make sense if I just simplified it? So I hit the edge of the island here, because before I accidentally did it on the word. So here and here.
But it's confusing because there's 14 in between.
That's why we're just going to estimate it. Okay, so what do you guys want to do for this one? 53 point? Sure, 53.8. Okay, so Henry says he recounted, there wasn't actually 10, so it's not 0.1, but it's close-ish to that, but there's 14 tick marks, so that's kind of... Each tick mark is worth 0.07. Okay, what'd you guys approximate over here? You have to be careful about your negative numbers here.
I've done the very, very technical calculations. It is technically 53.9.
53.9.
Do the very technical.
Why did you have to use the term technical?
It just makes you sound more nerdy. Technically.
How about watching this video on YouTube?
So is that because you counted 9 ticks? 9 ticks?
I did like, technically 11 or 14, so, I just.
If you did 9 ticks, it's actually 0.6. Yeah.
11 or 14.
Because each tick isn't exactly 0.1.
You said you did 11 to 14.
You did 11 ticks?
Yeah, it's 11, 14.
I was right, 0.7.
Well, you round up.
If you did 9 ticks, you'd be 0.6.
9?
How did you get 9?
Well, I don't know. It's an approximate, so everybody will be a little different. Yeah. Okay. Give me a number there, though.
100.
Give me a number over here.
Because we're just gonna argue this.
Negative 131, negative 130. Negative 131 is there. Negative 132 is there.
Negative 130.
What do we want to do?
0.8. 0.8. Negative 131.8.
Negative 131.8. Okay.
I thought Anna and Kaya. It's not today.
Yes, I can hear you. Technically, it's not.
My favorite one.
Say it again later.
Okay. I don't know if I'm going to answer this next one. I don't really. So, where she started sailing from. So, like we could backtrack here, but I don't honestly know if there is enough info. Okay. So, conclusion. Here's my conclusion. Ready? What does the back page of your notes or your booklet look like? Do you have anything blank? Is it any blank pages?
It's blank.
Blank. Go to your blank back page. Okay. Give me an understanding, a little picture. Independent, dependent, so relies on. Okay, that's one thing with graphs. Okay. Okay, what's the difference between these ideas? This is continuous. What does continuous mean? It exists between dots. Example, airplane. Okay, so it exists between the dots. Okay, this one, I don't think I've ever used this word with you, but it's a higher level word. It's called discrete data. And what do you think it is compared to continuous?
Non-continuous.
Non-continuous, so it doesn't exist between dots. And we had an example. T-shirts. We can't be 1.5 t-shirts in between the dots. Like, I can't buy a t-shirt right there. I can't buy 1.5 shirts. Okay, and we okay, then we talked about this when we analyzed our location based off of within. So that was called the interpolate. Okay, versus this one, if I was given the data here, but I'm asking you for something beyond, that is called extrapolate. Okay? But you guys know that you can take a ruler at any time and make that line as far as you really want, right? Okay. Lots of words today, I feel like.